Welcome, Hornets, and thank you for joining me today. Today we're going to be talking about trigonometry. Specifically, what if I already know a ratio? How do I figure out what are the other six trigonometric ratios that go with it? So let's go ahead and just immediately jump in. Let's assume that I'm looking at a cosine of theta, and I'm telling you that the cosine of theta is a negative 1/2. And then I tell you that the sine of theta is less than 0. Now, between these two bits of information, we can clearly see that our cosine being negative in a ratio is going to have to be in the second and the third quadrant. But because the sine is also negative, and that won't happen in the second quadrant, but does happen in the third, we know that our angle is sitting in the third quadrant. Not only that, but we also know that it has to be a 60-degree reference angle because of the 1/2. So I now know that the angle that I am working with is going to be 240 degrees. Based upon that 240 degrees, I also know that my sine of theta, which has to be negative, is negative root 3 over 2. Therefore, the tangent of a 60-degree reference angle is going to be positive in the third quadrant, and therefore I'm looking at a positive root 3. The secant can then be found, and the secant is the reciprocal, negative 2. The cosecant can then be found, and the cosecant has to be negative 2 root 3 over 3. And the cotangent can now be found, and it has to be a positive root 3 over 3, the reciprocal of each of those functions. So that's the idea of what we're talking about when we use trying to find these six trigonometric functions when we are given information regarding a triangle. So notice we're just talking about that triangle right here. Let's try another one. This time, I'm going to give you a point on the unit circle or on a circle, and I'm going to ask you to then find the six trigonometric ratios that correspond to it. And we're going to make this very, very straightforward. So we're going to go up here, and we're going to say that this point is 4, 3. That means that my height is 3, my length is 4, and you'll notice that I can use the Pythagorean Theorem. X squared plus y squared equals r squared or h squared or z squared, depending upon what you want to call it. So if I know that I have a 4 squared and I have a 3 squared, and then my square root of that should then be r, which is the radius of that circle. Notice that it's not a standard unit circle, and that's because our lengths are beyond 1. Please remember, the maximum in a unit circle is 1. So here we go. Square root of 16 plus 9 is r. The square root of 25 is r, and that tells me that r has to be 5. Now, once I know what my r value is, I can now find my sine of that theta, and that has to be 3 divided by the radius, and therefore 3/5. The cosine of that theta has to be 4/5. The tangent of that theta has to be 3/4. Taking the cosecant is 5/3. The secant, the reciprocal of the cosine, is 5/4. The cotangent of this has to be 3/4. This is also triangular trigonometry, where we're using a triangle in order to find our six trigonometric values. Let's go ahead and keep going, shall we? Because we've got a lot of different topics that we can do when we look at this concept. Let's take for a minute trying to find the remaining trig functions, working with negative 3/5, and I tell you that it is in quadrant 3. If it's in quadrant 3, our reference triangle looks like this, and I'm now looking at my x being the negative, and I need to make sure that I put it in the right place. My radius is always positive, and by the Pythagorean theorem, we can find that we have a -4 right there. Once again, that's -3 squared plus my x squared has to equal 5 squared. And therefore, x is the square root of 25 minus 9. That gives me the square root of 16, which has to be 4. We then put direction, being in the third quadrant, has to go toward the negative x. Okay? So now once I have my triangle, I can find all of my trig functions, starting with the one given to me, -3/5. Cosine of theta is -4/5. Tangent of theta is a positive 3/4. Cosecant is the reciprocal at -5/3. Secant is the reciprocal of the cosine, which would be -5/4. And our cotangent is the reciprocal of our tangent and would be 4/3. Once again, working with trigonometric values in order for us to find the remaining 6 trigonometric functions. Now, there is one last thing that I'd like to go over with you, because sometimes things are not always as easy as they appear. For example, what happens if they decide to give me a ratio that has a variable in it? Oh my gosh, a variable in it? Well, yeah. Let's say for a moment that I have the cosine of theta is simply the ratio x. Well, I'm going to make sure that I call it x divided by 1 so that I can see a numerator and a denominator. Since this is positive, I'm going to go ahead and I'm going to just make it in the first quadrant. Now, if they tell me it's in a different quadrant, I'll put it there. But they didn't tell me where, so I get to choose. So I'm going to make it in the first quadrant, and since cosine is the adjacent over the hypotenuse, I know my hypotenuse is 1, and the adjacent side is x. Notice that what I'm missing is this side here. From the Pythagorean theorem, we have our x squared plus our y squared equals 1 squared. And therefore, y has to be the square root of 1 minus x squared. And I'm going to put that right here. Just the Pythagorean theorem, and then simplified. But what this allows me to do is find all the other trig functions. So if I know that cosine of theta is x, I'm going to go ahead and I'm going to find my sine of theta, and that's going to be this piece, the opposite, over the hypotenuse, square root 1 minus x squared. The tangent of theta is going to have to be my opposite over my adjacent, and therefore the square root of 1 minus x squared over x. I'm now going to go ahead and find all of my other functions. The cosecant of theta starts off as 1 over the square root of 1 minus x squared, but we have to get the radical out of the denominator. That just moves the radical to the top, and I take away the radical in the bottom. Working with my cosine, the cosine is simply the reciprocal of x, and that would be 1 over x. Going to the cotangent of theta, I'm now taking my reciprocal, and it starts off as x divided by 1 minus x squared, and it has to be readjusted as well. X times square root of x squared minus 1 minus x squared over 1 minus x squared. And now we're looking at our 6 trig ratios based upon one fact. Let's try another one. This time, let's choose a quadrant, shall we? We're going to say that we have the secant of theta, and we're going to say it's 3 over x. I don't like 3 over x. Let's keep it simple and make it 5 over x, and we're going to say it's in quadrant 4. So we now have 2 bits of information. We're going to go to quadrant 4. We're going to draw our reference triangle. We're going to put in our right angle. Remember, this is theta all the way to here. This little piece right here is called theta prime for our reference triangle. Notice that we have our hypotenuse now is in the numerator, since it's a secant, and that gives me a radius of 5. The length going across is a positive x, and I can clearly see that my y value is going to have to be negative. Working with the Pythagorean Theorem, x squared plus y squared equals r squared. X squared plus y squared equals 25. Y then has to be the square root of 25 minus x squared. And when I put it on the unit circle or into the triangle here, I make sure I include that negative. I now can find my 6 trig ratios. Starting with the first one, we have the secant of theta is 5 divided by x. So I'm now going to find my sine of theta, once again in the fourth quadrant, is negative square root 25 minus x squared over my hypotenuse 5. That's going to make the cosecant of theta the reciprocal of that, and that's going to have to be negative 5 over the square root of 25 minus x squared. And when I move the radical into the numerator, I'm going to get negative 5 square root 25 minus x squared over 25 minus x squared. That's my ratio. Let's go ahead and do the cosine. The cosine is the reciprocal of 5 over x, which would be x over 5. And now I have the more difficult tangent of theta. Now the reason why this is more difficult is because I have two fractions. I have y divided by x, and the y divided by x is going to cause the 5's to reduce. So we're looking at these two right here. And I'm going to make sure that I put it as negative square root 25 minus x squared over 5 times the reciprocal 5 over x. My ratio becomes negative square root 25 minus x squared all over x. This is then going to make my cotangent of theta, and that has to be negative x over the square root of 25 minus x squared, and we have to get the radical out of the denominator. So I have negative x square root 25 minus x squared all over 25 minus x squared. And I now have all 6 trig ratios. Once again, this is not exceedingly difficult. Let me make sure I get the correct ratio that I want, as these have kind of been rearranged. So this is trigonometric triangular trigonometry. It's working with triangles, specifically right triangles in the Pythagorean Theorem, in an effort to find our associated values. So let's go ahead and just take a look at another one. This time I'm going to go ahead and we're going to solve for the unknown variables. I have a right triangle, I have y, I have x, I have a 45-degree angle, and I'm told that I have 3 root 2. Well, if I have a 45, 45, 90-degree triangle, I have to work backward. So before, when we began this, we started with those triangles. And we said, hey, wait a minute, if I have this information, then I should be able to use it. Well, according to our information, that is A and this is A because it's an isosceles right triangle. The problem is this x moves along the positive x-axis, so it's a positive 3, but this goes down, and therefore this value would be a negative 3. Notice how I am including direction. Down is negative, to the left is negative, and to the right is positive, and up is positive. Let's take a look at another one. This time, let's look at this triangle. And let's go ahead and put it in the third quadrant this time. This time I have x and y here, and I'm looking at negative 2 root 2. Now remember, this negative is simply giving me direction. When I work with the Pythagorean theorem, the direction is going to go away. So I have negative 2 root 2, the quantity squared, plus y squared has to equal the x squared. That means that x has to be the square root of 8 plus y squared. Now, if this is a 45, 45, 90 degree triangle, we're going to use the same relationship. And that means that if this is A, this is isosceles, which forces this to be a positive 2 root 2. Once again, it's going along the positive x-axis, so it's a positive. Remember, radius is always positive, and when I do this, I'm looking at 2 root 2 times root 2, a root 2. This is giving me 2 times 2, and I get 4. Now, once we have these types of variables in our unit circle or in our triangle, we can then find our various 6 ratios, which would be the next step. The last thing that I'd like to talk to you about is how do we use our ratios in order to find our angles. For example, let's assume for the moment that I have cosine of theta and it equals negative root 3 over 2. Well, unfortunately, there are 2 possibilities for this angle. One has to be in the second quadrant, and the other has to be in the third quadrant. And they both have a 30-degree reference angle. I know it's a 30-degree reference angle because the cosine of 30 degrees has the ratio root 3 over 2. So the question then becomes, well, what is the angles? Well, I need this angle here, and 30 degrees is the supplement, which means that this angle is 150 degrees. And then I have to go all the way through, and I'm now looking at 180 plus my angle, and therefore the second option is 210 degrees. Notice how in both cases I have 2 options. Once 2 options because there are 2 possible angles. And my answer would be theta is either 210 degrees or 150 degrees. Once again, this is solving trig functions. And we can do all kinds. For example, if I give you the sine of theta is 1/2. When is sine 1/2? That's going to be 1/2 in the first and second quadrants. And once again, it is a 30-degree reference angle because the sine of 30 degrees is 1/2. So my first angle has to be in the first quadrant, and it is 30 degrees. And in the second quadrant, it's the supplement of the 30-degree angle, and that gives me 150 degrees. Once again, 2 answers for theta. Let's go ahead and do another one. Let's do the tangent of theta is negative root 3. Alrighty, so we're going to first start by finding our tangent where it's negative. That's in the second and fourth quadrants. And in order to have a root 3, I have to have a 60-degree reference angle. And I need to make sure I put it in both places. So the first angle is the supplement, and that has to be 120 degrees. And the second is going to be 360 minus the angle. And I'm going to have to go all the way around. So I'm going to go 360 minus the 60-degree reference angle, and I get 300 degrees. Now, don't get too frustrated by this. After all, we already know that our reference angle, theta prime, is 360 minus theta. That means that theta has to be 360 minus theta prime. And that's all I did. I just took my reference angle and subtracted 60 using this relationship. So be aware that we can find our angles given a ratio, and we will be forced to do so. Alrighty, this is my lesson on triangular trigonometry, and this is what we will be going over in class. For those of you who had any difficulties, I hope this helped. And if it did, please remember to click like. All right? Thank you very much, Hornets. I appreciate you participating and watching this video, and I hope this has helped. Bye-bye now. Take care. Be safe. Be kind to each other. Remember, it's easy to be mean, so try to be nice to each other, okay? Cheers.